Okay, so welcome back to another video. So in today's video we got this little number theory problem. Specifically, this is question 3 from the 2015 American Invitational Mathematics Examination 1. And the question is, what prime number p makes 16 times p plus 1 a perfect cube? So again, this is based on number theory, and we're going to be dealing with manipulating with prime numbers. So let's do it. So the fact that we want to observe is that we want to note that 16p plus 1 is actually an odd number. So recursively defining, odd numbers are defined as the following as 2a plus 1. And then even numbers are defined as 2a, such that for some a, that's actually a natural number. Okay, so we get the basics of that. So I'm sure everybody knows about that. So now we want to find a prime number p that makes it a perfect cube. So we know that 16p plus 1, it has to be an odd number. No matter what positive integer you plug in, you're always going to get an odd number for this equation here. So what I can do is I can set 16p plus 1. We can set the equation equal to a perfect cube, but that means that it has to be an odd number. So that means we replace with our 2a plus 1 and cube that. Okay, and so I'm going to expand. We're going to expand this cube over here. So let's see. So 2a plus 1. Okay, and then this is expansion of 2a plus 1 square. So this is 4a square plus 4a, and then plus 1. And then just do it again another time. Multiply that with 2a plus 1. So I get that this is a8 cube plus a8 square plus 2a plus 4a square plus 4a, and then plus 1. Okay, now we just combine our terms. So this is 8a cubed plus 12a square plus 6a, and then plus 1. Okay, and I'll just substitute this back in, plus 1, and our cubic equation over here, plus 12a square plus 6a plus 1. And then I'll subtract the 1 from both sides, so that means both the 1s from both the left and the right, they cancel. And so we're left with 16p is equal to 8a cubed plus 12a squared plus 6a. And then I can actually divide by 2 from both sides, so that we get 8p is equal to 4a cubed plus 6a squared, and then plus 3a. And now how about I actually factor out an a from the right side of the equation. So we get this is ap, and then a is being multiplied by 4a squared plus 6a, and then plus 3. Okay, so far that's what we have with our equation over here. So let's pay attention to the inside expression 4a squared. So 4a squared plus 6a plus 3. Okay, now I can actually factor this 2 out from the 4a squared plus 6a. So it's 2a, or 2 times 2a squared, and then plus 3a, and then plus 3. Okay, so now note that this is actually an odd number, so I'll put that as odd. And you can see that obviously we can tell that because recursively defining an odd number is 2a plus 1. So let's say that 2a, or 2 times some natural number n, or rather this is a in this case, I should have said that. Okay, and then plus 1, and then plus 2. Okay, so let me just label what we have. So over here, this expression in the parentheses, we get that that's an odd number, and then you know that this is an even number. So when you add an odd and an even number, you're going to get that it's going to equal an odd number itself. So this means we come to the conclusion that 2 times 2a squared plus 3a plus 3 is odd, or rather 4a squared plus 6a plus 3 is an odd number. And because that the right hand side is odd, then we can see that clearly for it to equal each other, the left side has to be odd. So that means p has to be an odd number, and it's obviously you can see that because p cannot equal 2, since 2 is actually the only prime number that's even. Let me just write that 2 is the only even prime number. Okay, so that means we can actually come to the conclusion that and p such that p has to be odd. We can conclude that p has to equal this following equation. So p is equal to 4a squared plus 6a plus 3. Okay, cool. So now we have what our equation for p is, so let's actually substitute our p back into here. So 16p, or 8. I wanted to say 8. So 8 multiplied by our equation 4a squared plus 6a plus 3, and then that's equal to a times 4a squared plus 6a plus 3. I can actually divide both sides with the equation 4a squared plus 6a plus 3. Same thing from this side here. And we get that they cancel, so therefore a has to equal 8. And we just mark the cross out here. So this cancels and then this cancels, so we're left with that a is equal to 8. And now that we found our value for 8, so now let's actually do the calculations. So this means we have that p, which is 4a squared plus 6a plus 3. So that means we plug in p is equal to 4 times 8 squared plus 6 times 8, and then add 3. So this means this is 4 times 64 plus 48 plus 3. Expand this out. Let's see, 4 times 64, that's 240 plus 16, 256. Plus 48 plus 3 is 51. And we have come to the conclusion that p has to equal 307. So to conclude, what prime number p makes 16p plus 1 a perfect cube? P has to equal 307. That is really cool with this kind of number theory problem here.